Okay, here is 10.4 is an inscribed angle, and polygons is 45 through 46. Your table of contents. On page 45, Theorem 10.7 says measure an inscribed angle theorem. It says an inscribed angle is the one that is on the side of the circle. So D is an inscribed angle because it's not from the C. C is a central angle, and D is an inscribed angle, so it's all the way across. Make sure the angle, the points are all on the circle, and the arc that is the end of the angle A to B, because it's the ends of the angle, is called an intercepted arc. Just so you know. And it says that this angle D will be half the measure of the arc. So here I put an example that if the arc was 60 degrees, the central angle, if it was drawn, would be 60 because it equals. But since it has to travel all the way across to the other side of the circle, it's going twice the length. That's why it is reduced by half. If I was going from D all the way to the arc, there is traveling twice the distance, so it's multiplied by 2, or it's divided by 2, whichever way you're going through the circle, back and forth. Okay, here on example 1 it says use inscribed angles, find the indicated measure of a P. If I'm looking at this one's angle S, right here, S is an inscribed angle, and the intercepted arc is 60, so all the way across means you have to divide it by 2. So 60 divided by 2 is 30, so the measure of angle S is 30 degrees. And it says find arc RQ. This is 37, so to go to the arc, that means you have to multiply it by 2. So it would be 37 times 2, which means that arc measure is 74 degrees. Okay, if I look at example 2, it's saying I want to find the measure of the intercepted arc. It says find HJ. HJ is right here on my picture. It is that arc. It does have that curve over it. The inscribed angle is 39, so going all the way to the arc means you have to multiply by 2. So 39 times 2 is 78. So the measure of arc HJ is 78 degrees. And then it wants you to find the measure of angle HGJ, which is that little angle here. And notice the ends of this angle are J and H, so that intercepted arc once again, which was 78 degrees, bring it all the way back to G, and notice that it's going to be divided by 2. If I divide by 2, then I'm going right back to where I was, so I have the measure of angle HGJ will be 39 degrees. So notice that when they have the same intercepted arcs, the inscribed angles will be congruent to each other. Okay, I have theorem 10.8. It says if two inscribed angles of a circle are intercepted the same arc, then the angles are congruent. So that's what we just showed on this problem, was that example for this theorem. So it says here that on your next example says name two pairs of congruent angles in the figure. So if I look here, I'm sorry, this problem's already been worked, but my machine messed up. That if I have PQ, the angles here, I'm going to do it with a highlighter here so you can see that PS and QS are the intercepted arc or angle, is also going to be PR and QR. So let me put it on a different paper here so you can kind of see it, that this arc here has this angle as well as this angle that you're looking for that relationship. So you have this arc is looking for that one. So if I was to answer this, that would be angle PSQ will be congruent to angle PSQ would be PRQ for one set. And then you got to see this thing flipped over, that this angle here, SPR, with SQR have this arc in common. So that means those angles at the top here, right there, are congruent to each other. So I'd say that angle SPR is congruent to angle SQR. Notice on these it has a P, SQ, and PRQ. The ends are the same, P's and Q's. On the second one, it has S's and R's on the ends, and the only thing changing is the vertex. So that is showing you how the arcs are the same, because the arc that you're looking at here is SR and SR, and this one is PQ with PQ. Okay, Theorem 10.9 is emphasizing the fact that we can have, when we have the diameter given to us, the AC is our diameter. Remember, this is a semicircle, so the measure of that central angle is 180, which means this arc is 180 as well. And if you draw lines from the ends of your diameter to point B, this will be a right angle, because this becomes an inscribed angle. And if this is 180, if I bring it all the way across and divide by 2, that means this angle has to be 90. And what is unique is this creates a right triangle here inside of our circle that we actually have, and we can find lengths of chords real easy using Pythagorean theorems. Okay, on page 46 at the top I have Theorem 10.10, and it says, okay, if we have a quadrilateral that is actually inside a circle, remember a quadrilateral adds to 360, but what is unique here is that opposite angles, what makes us so different from the other quadrilaterals we're just in, is the opposite angles will actually be supplementary to each other. So that means E and G will equal 180, as well as D and F will equal 180. So that is something very unique that happens when you put a quadrilateral inside of a circle. It's a different property. Alright, if I look at our last example here, let me pause and zoom in. Okay, on this one, it wants us to find our variables and realize we're dealing with a quadrilateral inside a circle. So 88 and x will be supplementary. So that means I'm going to take 88 plus x equals 180. I'm going to subtract the 88. And x is equal to 92 degrees on that problem. And then if I look for y, remember y and 100 will be supplementary also. So that's 100 plus y equals 180. Subtract the 100. And y is equal to 80 degrees for A. There's two answers. Okay. If I look at part B, doing the same concept, just looks a little different. I'm going to do with the x's first. I have 8x and 4x. I'm going to add those two things together, but they're still going to equal 180 degrees. 8, 9, 10, 11, 12. X is equal to 80, sorry. Divide by 12, and what is that? How much is that? 12. Oh, that's 15. So x on this problem is 15. Now, I did not put a degree on there because the x is not independent. It's got a coefficient with it. If I look at the other direction, let me change colors. This has 3y with 3y. That means that's 3y plus 3y. It's still going to equal 180. So that means that's 6y equals 180. If I divide by 6, y equals something. What does y equal? It equals 30. Okay. Now you have independent problem number 1. Copy down and work. There's independent practice number 2. Copy down and work. There's number 3 that you can copy down and work. And then there is number 4 that you need to copy down and work. And then start the video again and see if you have the correct answers. Okay, number 1, it says GHJ is what I'm looking for. The intercepted arc is 100, so I'm going to take 100 and divide by 2, means that angle is 50 degrees. Number 2 tells you the intercepted arc is 40, so to get to the, inscribed angle is 40. The intercepted arc is what you're looking for, so you double it. Means this is 80 degrees, and there's your answer. Okay, number 3 wants to know what RTS is. If I look at the 31, it's an inscribed angle. Its intercepted arc is RS, which is also tied to the angle T that I'm looking for. So that means if I go to this, it's doubled. That means this is 62, and then when I go back this way, I divide. That means that angle is equal to 31 degrees. Remember, those angles will be congruent when they have the same intercepted arc. And then on practice problem 4, we've got to find A and B. If I look at A, have 5A plus the box, which that means, that means plus 90 equals 180. I subtract the 90, and I have 5A is equal to 90. Divide by 5, and A is equal to, what is that, 18? Then if I go in the other direction, looking at the B's, I have a 4B plus the other opposite angle, which is 96. That is equal to 180. If I subtract the 96, that gives me 4B is equal to 84. If I divide by 4, that means B will be equal to, what is that, 21 for that problem.